All right. Our question one says that a ramp leading into a building is constructed such that the difference in height between the height end and lower end is 5 meters. The entire horizontal length of the ramp is 35 meters. Calculate the slope of the ramp. Good. And the sketch looks like this as we are seeing over here. Okay. So this is the horizontal distance of 35 meters, and also this is the rise. Okay. So basically, we can say that slope is the ratio of rise to run expressed as a percentage. Okay. Without wasting much time, let's quickly see if we can bring out the given. Okay. Then from there, we use that to solve our problem. As simple as that. So let's quickly write here given. But before that, let's see if we can divide this into two. Very good. So we can begin. So let's quickly put down a given. So we are saying that our slope is equal to rise over run expressed as a percentage. Okay, so first of all, we want to put our formula here even before we start to write the given. Okay, that is what we know since we just realized that the question is about slope. So our slope is equal to rise over run. Rise over run expressed as a percentage. This should be the first thing that should come in our mind. Okay, now or or the change in elevation, okay, or change in vertical height over the horizontal distance. If they say change in something, it's definitely the final one minus the initial one. Okay, exactly. So let's now proceed to write down our important points. So let's go back to the question again. Let's quickly go back to the question again. And the question says that a ramp leading into a building is constructed such that the difference in height between the highest end, okay, that is the highest end over here, and the lowest end is 5 meters, and this lowest end is what? 5 meters. So it has already been calculated. Now the entire horizontal length is 35 meters, and this is it over here. Calculate the slope of the ramp. So as you said, slope is expressed as the hot, the ratio of rise to run expressed as a percentage. Slope is equal to the ratio of rise to run expressed as a percentage. Or it can also be expressed sometimes in terms of what? Uh, 1 and n. Yes, good. So let's quickly proceed. So in this case, our rise, our rise is equal to 5 meters, and our rise and our run is equal to 35 meters. You see, so you see, slope has no unit because at the end of the day, both units will cancel each other. Always remember to do your conversions. Always remember to do the conventions before you work them out, okay? Because if they are not equal, at the end of the day, the unit will even split the truth. Okay, so let's proceed so we can continue our solution over here. So this is our solution. Exactly. 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 Also, don't forget to subscribe to the channel so that anytime I release a video, you will get a notification even when I don't send you the link. Yes, it's not all the videos that I will be sending you the link. Don't forget to also like, comment, and share. And also, your feedback is needed to improve the quality of the video and also the level of understanding. Exactly. So we said our slope is equal to rise over run, expressed as a what? A percentage. Uh-huh. Let me quickly write this. Let me quickly write this. Well, exactly. Okay. So now we can proceed to solve our work. So at this case, we can repeat the formula. So in that case, we are saying that slope, the slope is also known as the M. Okay. So this is the slope, okay, or the gradient is now equal to, let's say, the rise, 5 meters all over 35 times 100 times 100. So at the end of it, you realize that meters is going to take care of meters, okay? Um, and 5 will go into itself one. 5 will be going into itself once. You'll be going into 35 how many times? Let's all quickly do that. Put that together on our calculator. I urge each and every one of us to have a pen and a paper beside it so that at least we can be able to jot down some important things. 5 times 7 is going to give us 35. Exactly. So you realize that 5 is going to go into itself one time. And at the end of the day, it can also go into 35 times 7 times. So finally, we can say that what our gradient, if I say gradient, don't get confused because the gradient is the same as the slope. Mhm. So our gradient is equal to 1 over 7 times 100 times 100. Exactly. Exactly. So let's quickly point this together on the calculator. Let's quickly point this together on the calculator. So we say 1 over 7 times 100. And what are you going to get? You're now going to get 14.2857, okay? But you can just maintain 2 decimal places, okay? So you can just maintain 2 decimal places. So finally, we can say that, so therefore, our slope, our slope is equal to 14.28. Exactly. But we said that also slope can be written as what? 1 in n. Okay. I mean, like, we're going to compare this answer to 1 in n. Yes, we are going to compare that answer as to 1 in n. But since you say slope is always expressed as a percentage, don't forget to add a percentage sign, okay, to your answer so that at the end of the day, you can always be on the right path. You can always be at the right path. Mm. So we are saying that we can also write 14.28% as a ratio 1 in n, as a ratio 1 in n. Exactly. Exactly. So we are just going to do that now real quick. Exactly. Okay. Let me quickly number the page. So we are putting asterisk over here. And that asterisk simplifies that. We can write 14.28 as a ratio 1 in what n. So let me quickly jot that down to make life easy. Okay. So this is it. We can also write 14.28% as a ratio 1 is to n. Okay. Exactly. 1 is to n. So we are just going to solve that now to make life easy. Mhm. Okay, so that is what we are seeing. That is what we are seeing. So let's quickly relate that to whatever we are saying, and then let's verify if that is true or not. So finally, we are going to be getting this, and whatever we are saying theoretically, mathematically, this is the meaning. 14.28% is equal to 1 is to what? N. Now, and I want each and every one of us to take note that. Please take note that 14.28 can also be written as a fraction, and that is 14.28 over 100. Okay, over 100. Now we can bring our equals to. You know that this is a ratio. If I say 1 is to 2, then it means that 1 is to 2 can also be written as what? 1 over 2. If I say 6 is to 8, it means that 6 to 8 can also be written as what? 6 over 8. So let's transfer the same knowledge over here. You see, so that is you're going to be getting 1 over n. Okay. From whatever we learned, from whatever we learned from the previous lectures, you realize that whenever we meet something, you are supposed to do cross multiplication. Okay. So you're going to be doing cross multiplication over here. So 1 is going to multiply the 100, and n is going to multiply 14.28. At the end of the day, we have to make n the subject and look for n. So finally, that is going to mark us to getting an equation such as this. 14.28 14.28 times n is equal to 1 times 100. At the end of the day, we're going to be getting 14.28 n. That is 14.28 n. if you see this multiplication, 14.28 is equal to what? 100. Now we want n to stand alone. So you realize that we're going to be getting something like this. N, because you have to divide both sides. Okay. So you're going to be getting something like n is equal to 100. N is equal to 100 over 14.28. Okay. 100 over 14.28. So what have we learned? You just realize that if you want to write something as 1, it's just the reciprocal of that. If I say reciprocal of that, it's just the reciprocal of the percentage itself. Okay, because 14.28% is the same as 14.28 over 100. Okay, and in writing it as 1 in n, then it means that it's going to be 100 over 14.28. Good students should have been able to jot this down. Thank you. Thank you. Thank you. So let's quickly work this out. Let's quickly plug this together. 100 over 14.28. And you realize that we're going to be getting 7.00. Okay. So finally, we can say that therefore, our n is equal to 7.00. 7.0028. So this is it. We are done. We are done with the work. Please, if you have any question, any comment, don't forget to type it in the comment section. Also, don't forget to like the video, share, and follow for more. Also, don't forget to subscribe to my YouTube channel. All right. All right. Let's continue to see how we can go about question 2 also. Okay. Question 2 says that a map has a scale. A map has a scale of 1:1,500. Okay, good. And with contours as shown below. All right. What is the contour interval? What is the contour interval of this map? And also, B is telling us to calculate the slope between the 2 points shaded red if the distance between these 2 points on the map is 5 centimeters. All right. All right. Let's quickly write our solution. So let's come back again. A map has a scale of 1:1,500 and with a contour as shown below. What is the contour interval? Okay, so as you can see, this is a mountain over here, and then the mountain, this is the difference in elevation. Okay, you can see the upper point and then the lower point. Okay, so all these are what contour intervals. They tell more about heights. Yes, so to get a contour interval, you see that they are in sequence and there is a common interval between them. That is 50 minus 40 will give you 10. Okay. Yes. Also, you have to know that 40 minus 30 is also going to give you 10. Take note that this same 30 minus 20 The 30 minus the 20 is also going to give you 10. The last but not the least, 20 minus 10 is also going to give you what? 10. Take note, 10 minus 0 will still give you what? 10. Exactly. Exactly. So it is well defined. Do you understand me? So once you're able to check for all these factors and they are uniform, then you know that you're on the right path. Let's proceed with solving our question. So from this experiment, we have just realized that our contour interval is what? 10. Our contour interval is 10. And the contour interval is defined as the difference between the numerical value of consecutive contours. This value is 10 meter, obtained by either 50 minus 40, 40 minus 30, or 30 minus 20, just as we have what all practiced over here. So that is it. That is it. Let's quickly write our solution over here and put it down there. Good. So we are solving for A, and our contour interval so that becomes our contour interval. Exactly. Exactly. So we are coming to calculate for it. So just as we did over there, we will repeat 1 or 2 over, and that will be 4. So we said that what? 50 minus 40. 50 meters minus 40 meters. So what we think. Also, what else can you realize? 40 meters minus 30 meters. Is equal to 10 meters and so on. So therefore we can say that our contour interval therefore we can say that our contour interval is equal to 10 meters. Exactly. Therefore, our contour interval is equal to 10 meters. So we are done solving our question. Let me see 1A. Let's quickly look at question 1B2 and see how best we can be able to solve it better. So this is our question. Calculate the slope between the 2 points shaded red in the distance between these 2 points on the map is 5 centimeters. Good. So they have given the distance between these 2 points on the map, okay, as 5 centimeters. It's 5 centimeters. And we are being asked to calculate for the slope. We are being asked to calculate for the slope. Exactly. Take note that since the ground distance is 5 centimeters, therefore the ground distance is calculated using map scale as follows. Okay, as we are just meant to do. Okay. So it is still the same question. You see the one on the land. We are still using the same question when they're confused. That is why each and every day I still come back to read the question. They say a map has a scale of 1:1,500 and with contours as shown below. Now they ask you a question, what is contour interval on the map of this map? You have been able to tell. So it's still the same question. Don't let it confuse. So first of all, you have to be able to pull down the map scale. Okay. Then at the end of the day, you compare your values with it. They've given you, they say you should calculate the slope between the 2 points. The shaded red. You can see the point shaded red. This is one over here. This is one over here. And if the distance between these 2 points is 5 centimeters, what are you supposed to do? You realize at the end of the day, all this distance over here in meters, so all this distance, the 50, 40, the contour intervals, they are in meters. So it means that you have to also convert this 5 centimeters to meters, okay, before you can be able to use it to work. Yeah. And take note that 100 centimeters is equal to 1 meter. Yes, 100 centimeters is equal to what? 1 meter. 100 centimeters is equal to 1 meter. Exactly. So let's quickly apply that concept and see how best we can become history. So the slope, we're actually calculating for the slope. So we calculate the slope between the 2 points. So that's the slope between 2 points. Slope between 2 points. Exactly. So they've already given us our map scale. So the map scale given us to us was, let's write the map scale down. The map scale they gave us was equal to what? 1:1,000. Let's quickly look at it together. 1,500. Okay. So that scale that was given to you, we have to compare it to be able to solve our work. Okay. This is a key and essential information to solving the work. So this, we can now compare this to our information. So this can also be written as 1,500. All right. Which is equal to, let's say, 5/x. Okay. And in saying all of this I'm saying over here is also the same as this. Please don't get confused. Using get confused. So that is 1:1,500 is equal to what? 5 is to x. It's not necessarily 5, or it's actually 5 centimeters. Okay, is to x. Um, exactly. So you have to convert the 5 centimeters into meters. Okay. So let's quickly do that together. Let's quickly do that together. So we're going to say but 100 centimeters is equal to, but 100 centimeters is equal to 1 meters. So therefore we can say that what? Therefore 5 centimeters is equal to, we can write that in meters. Okay. Um, or better still, we can work them out. But our answer has to be in meters. That is the main issue. Our answer has to be in meters. So from if we want to transfer that concept, look at what is going to happen. So if this is what we are saying, now we have what? 5 centimeters. Okay, is to what? X. So you just have to do cross multiplication. After your cross multiplication, you realize that x is going to be equal to 5 centimeters, okay, over 100 times 1 meter. You see, so at the end of the day, this is what is going to happen. Centimeter will take care of centimeters, and then we're going to be left with x is equal to 5. X is equal to 5 over 100. Okay, exactly. Which is the same as 0.005 Now we have to compare this 0.05 meters to our work to solve it. We have to compare the 0.05 meters to complete the calculation of our work. To complete the calculation of our work. So now wherever we put 5 centimeters, we can put 0.05 meters over there. So watch, I'm going to rewrite this equation again. And this is a very important equation that we established. Exactly. We are going to rewrite that again. So that is 1 over 1,500. One over 1,500 is equal to 0.05 meters. 0.05 meters all over x. So from here it's a matter of multiplication. From here it's a matter of multiplication. So let's all multiply 1,500 times 0.05. And realize that we are going to get 75 meters here. If I'm saying that, I mean that x is going to multiply 1, okay, which is equal to 1,500 times 1 point, or let me say this 0.05. So this are going to multiply. Okay. And at the end of the day, x, or let me say at the end of the day, x is going to be equal to 75 meters. 7. So if you also want to express it as one, and it can also be done. Okay, can also be done. But take note that we are not done. Over here, we just converted it into a ground distance. You understand? Because first it was on the map. So we just converted it into what? A ground distance. So now we have to now come and use it to calculate for our slope. You understand? Since we said slope is equal to rise over run. Okay. And the rise is also the same as what? Difference in elevation. Okay. Or the difference in height. Take note of some of these important things to enhance your learning process. Very, very good. So let's finally calculate for our slope. Let's finally calculate for our slope. Let's go back to the question to see what the question really what's the slope between 2 points. But let's go read the question one. A map has a scale of 1 is to 1,500 and with contours as shown below. What is the contour interval of this map? Calculate the slope between the two shaded red in the distance between these 2 points on the map. You see now, so it is as simple as that. So we have to now calculate for the slope. So we know that the slope is equal to what? The rise over 1. All right. So slope is equal to rise over run expressed as a percentage. Okay, exactly. Exactly. I believe that we all know our ground distance. Okay. And we all know our horizontal distance. And our horizontal distance is simply our 75 meters we calculated for. 75 meters we calculated for. So the 75 meters is the run. Because if you come to the question and you study the drawing, you see the difference between the 2 points. Okay. The 2 points that we use this to calculate gave the what? But at the end of the day, gave The run, that is the horizontal distance. Okay. At the end of the day, we need to find the rise. Okay. Of which we have to subtract the what? This 10 from the what? 50. Okay. To get that. So let's see how we can go about that. So with this concept, we can say that what? But but our rise is equal to 50 minus 10. Which is going to give us 40 meters. Also, our run is equal to 75 meters we calculated just earlier. Okay. So finally we can combine all and you realize that life is going to be easier. So our slope, so the run, we put it over here, 75 meters. Okay, then we come to the numerator. So you see 40, 40, that's it. Times 100. So the rest is a matter of calculation. But let's all punch it together on a calculator and let's see the answer we're going to get. So you already know that meter will cancel meters. Okay, so 40 over 75 times 100. We're going to be getting 53.33. You're going to give us recurrent decimals. Yeah. So finally, we can say that our slope is equal to 53.333. Exactly. Exactly. So let's go to the next question and see how we can be able to play with the other question too. If you want to write it as 1 and n, it's just a matter of repeating whatever we did initially. Okay. It's just a matter of repeating whatever we did initially. Let's see if we can be able to apply that same concept over here. Okay. Okay. So I'm just going to edit this and you realize that life is going to become much more easy. So you say 53 point 333 cents. Okay. Let's quickly change the color to a different one. So that is to say that at say that at but we can also write 53.333 as a ratio. Okay. And if you want to do that, as we have learned earlier, it's just going to be hot 53.33. Let's just repeat it to two decimal places. So 53.33 percent can be written as a fraction. Okay. So all over 100 is equal to 1 in n. The rest is a matter of course multiplication, and then you become much more useful. So let's quickly do that together. As I told you initially, it's always just the reciprocal of the other one. We realize that finally our n is going to be equal to 100 over 100 over 53.33. So at the end of the day, we just have to all point this together. Quickly point this together and let's all put this together. Quickly point this on the calculator. So 100 over 53.33. What are you going to get? We say we want to just maintain two decimal places. Okay. Or if we like to, we could still maintain, we could still bring it to, okay. So 53.333 all over. You're still going to get your answer right. Okay. The laws of surveying are the same for all observers in uniform motion relative to one another. So that is it. 100 over 53.3333. We're going to get 1.87. So that is equal to 1.87. So that is it. That is going to be the value of n. Okay. Therefore, we can say that n is equal to 1 point, or we can even say n is equal to 2. Okay. So the slope of, let's say, 53.33% can also be written as 1 in that. Okay. So whatever I'm saying, I've just been saying that therefore n is equal to 1.875. Okay. So we can say that the slope can also be called 1 in 1.875. Okay. Slope can also be written as this. The slope can also be written in this. Okay. So let's quickly see how we can go about uh, question 3. Just like the previous ones we solved, it's very, very similar. Okay. So the question is saying that express the following gradients as percentages. Express the following gradients as percentages. When you see such a question, what should be the first thing that should come in your mind? What should be the first question that should come in your mind? Okay, now you just have to uh, use the gradient formula, okay, to solve it. You have to use the gradient formula or the slope formula that I taught you. Can you see this over here in the question? The question says express the following gradient as a percentage. Express the following gradient as a percentage. So this, when you see this one, it's like what we saw. We had the answer in what? We had the answer in a percentage. Okay, look at, we had the answer in a percentage. But at the end of the day, we want to express it as was one in something. So this time, it's just like we are doing the opposite of whatever we did. Okay. If you reverse the process of this, you still get that. You reverse this process, you are still going to get that. Okay, this is what 1 over what 1.875. Okay, what did we say about gradients? We said that gradient m is equal to what? The rise over run times 100. Okay, yes. And from that concept, to convert whatever we are having, we just have to multiply it by 100 and you realize that life is going to be much more easier. Okay, so 1 point, let me say 1 over 1.875 times 100. You see that at the end of the day, we are still going to get our 53.333. Someone said that we should all practice it. We should confirm that on the board. Yes, I'll be doing that quickly. And whatever I've been seeing, this is an evidence of that to still get an answer back. So look at what is going to happen. So this is, since this is already a slope, you just have to multiply it by 100. And that is 1 over 1.875, okay, times 100, all times 100, all times 100. Okay, and at the end of the day, you're still going to get you 53.33%. So that is it. That is it. These are some key points I wish you take serious. Let's all take some of these key points serious. Let's all take some of these key points serious. So let's proceed. So the solution of this is just as simple as that. So this is our solution. With this as solution. So we are starting with question 1AI. It's 1AI. So since we said that our gradient, okay, but before we begin, let's pull down the rule which we all follow. Okay, but we are saying that our gradient gradient or slope is equal to, let me say, the rise over run expressed as a percentage. Okay. Or let me say 1 in n times what? 100. Can also be written this way. Can also be written this way. Okay. Can also be written this way. Can also be written this way. So straight from this formula, we can quickly solve our work. Take this formula also very, very serious. This is also a very serious formula I just gave you. Good. Good. So we can now pick our question 1A. So that is AI. So from the idea, from our idea we just learned, we are just going to be multiplying. So you can say that our x now is equal to our x is equal to our x is equal to 1 over 10. Our x equal to 1 over 10. 1 over 10 times 100. So this is for 1 in 10. Okay, this is for 1 in 10. Let's go to so let's quickly point this together. You realize that from here, this 0 can even take care of this 0. So at the end of the day, our answer is going to be 10, right? Which is going to give us, so you can say that finally x is equal to, finally our x is equal to 10%. Since it's a gradient to a slope, we should always leave our answer in percentage form. All right. So let's proceed with II. The same procedure. Gradient is the same as x. That is why I'm representing it by x. Please don't get confused. So we are doing for 1 in 50. So this is 150. So we're going to say that x is equal to 1 over n times 100. Okay, so we just apply that same concept. Our x, which is the slope, or m, let's use m in this case. M is the slope. So that is 1 over 50. 1 over 50. So 1 over 50 times 100. So at the end of the day, let's all do that together. 1 over 50 times 100. And we are going to be getting 2. Okay, just 2%. 2. So the answer is going to be 2%. So you can see that therefore slope is equal to 2%. Therefore our slope was equal to 2%. So let's do for the I and proceed. All right. So let's proceed. So we had 2%. Okay. So let's proceed with I. So that is one in 16.67. Now this is the one we're converting now. So we are quickly going to work on that real quick and proceed. So as we all know, our M is equal to what? 1 over N times 100. Okay. In this case, our N is equal to what? 16.67. 16.67. So finally, we can say that our M is equal to 1 over 16.67. So that is it. It's 100. What are we going to get? Let's all quickly point this together. Let's all point this together. So that is 1 over 16.67, okay, times 100 times 100. And what are we all going to get? We're going to get 5.99, okay. We're going to get 5.99%, okay, which I think should be run. So this is it, but I'll be running it elsewhere. So therefore, we're going to say that our slope is equal to 6%. Slope is equal to 6%. Yeah, so please let's quickly proceed with question B. Okay. Let's proceed with question 3B. Let's quickly proceed with question 3B. So the question 3B, what does it say? A grid line is labeled as 500-meter east. What should be the label of another grid line 50 meters to the east of it? So we were told a grid line is labeled 500-meter east. Another grid line is 50 meters east of it. So that's what we are supposed to do is that the ME means meter east. Okay, this ME you are seeing over here. The ME means meter east. So 500 ME is the east coordinate of that grid. Yes. So what we are just going to do is that we are just going to add the offset, and that is all. Adding 500 plus 50 is going to give you 550. Then at the end of the day, we can say that the new grid line will be labeled 550 ME. Yeah, so this is not anything too complex. That is, if we want to bring this to basis in our solution, we can say that let's take it this way. Mm. Let's take it this way. So, first of all, our ME, I just told you millimeter unit. So at the end of the day, this ME, okay, is equal to what? Meter east. See, also 500, also 500 meter east. Okay, um, is the east coordinate of that grid. You see, is the east coordinate of that grid. The east coordinate of that grid. Is the east coordinate of that grid. Exactly. You see. So let me quickly put some steps behind them. Now we can just solve quickly, and we are good to go. I only want you to know the difference between some of these important basic points. Yes, important basic points. But what we're only going to do is that we're going to add the two. Okay, we're going to add the offset, and that is uh, the other grade, 15 meter of the east. We're just going to add it. So that is, we're going to be getting 500 hertz ME plus 50 meter to the east. We are going to add that to. Okay. Someone is asking why. I remember in level 100, second semester, we learned, even in senior high, we learned that in physics, when points are moving in the same direction, we add them, but when you're moving in the opposite direction, we subtract. So if you also draw that same idea over here, you realize that at the end of the day, it's still working. That is why I will continue to say that the laws of physics are the same for all observers in uniform motion relative to one another. So that is going to give us what? 500 plus 50. You see, good. It is equal to 550. Exactly. So finally, we can just write the new label, or we can write the new label 550 watt. And you see, so therefore the new grid line will be labeled as that. So therefore, let me put this over there. So you see, the new grid line will be labeled the new grid line will be labeled as, let's say, 550 meter east. You see, good. Wonderful. Exactly. 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 So that is what we are going to get. Okay. Now that is what we are going to get. So therefore, that is what the new grid will be labeled. That is how the new grid will be labeled. Okay. So let's quickly go and look at our second question. Let's go and look at our question C. Let's look at our question C. And the question C says that 2 points are 12 centimeters apart on a map whose scale is 1 point, or whose scale is 1:200. The points are located on the 52 meters and 15-meter contours, respectively. Calculate the average gradient of the ground between 2 points. Okay, yes. So, without wasting much time, let's just proceed from the solution. Okay, we just pick the informations and then that will be better. Okay. So some of the points that we have to know is that 2 points, 2 points are 12 centimeter apart on the map. And also the map scale is, let's say 1:200. Okay. The elevations, let me say 1 point on 52-meter contour and the other on 50-meter height contour. It should tell you about something. And the question is trying to calculate the average gradient. Okay, average gradient. If they say average, you should draw your mind to something. Okay, but we're going to work that out together. Okay. So first of all, we have to convert the map distance to ground distance. Okay, so first of all, we have to convert the map distance to ground distance. So let's put over here. Step one. Let's put over here. Step one. So we know that our first, even we know that our scale is equal to what? Our scale is equal to what? The map distance over the ground distance. Okay. So at the end of the day, if you want to get, let's say, if you want to get our ground distance, you just have to make one the subject. Okay. Better still, too, if you don't like that approach, you can just use the straight method. Okay, that is, we can say that our ground distance. We can say that our ground distance or Shindi. Yes. So let's write that together over here. Our ground distance. Our ground distance is equal to the map distance times the scale. Okay. Go to the map distance. The map distance exactly times the scale. Map distance times the scale. So this is it over here. We are going to use this to solve our question right away. Okay, so that is going to give us our ground distance. Let me say this is going to give us our ground distance to be equal to what? A map distance. And the map distance from the question is what? The map distance on the question is 12 centimeters. The map distance on the question is 12 centimeters. And then the scale is what? You can see 200. So we just use that to do our multiplication so that our it can enhance the process. Okay. So from here we can now say that 12 centimeter times 200. So this is 12 centimeters, okay, times 200. The scale will also be the n. Don't get confused. So this is going to give us our ground distance to be equal to 2,400 centimeters. 2,400 centimeters. Okay. But since we said 100 centimeters is equal to what? 100 centimeters is equal to 1 meter. We divide this by 100, you're going to get 24 meters. Okay, which is the same as what 24 meters. Which is the same as 24 meters. Okay. So therefore, we can say that our horizontal distance is 24 meters. So our run become the 24 meters. Um, so I'm going to put over here, you say that of our run. Our run is equal to what? The ground distance, which is equal to what? 24 meters. Exactly. 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 So in our step two, we have to calculate for the rise also. You have to look for the rise also. You see all this calculation you have been doing is for the run. The ground distance, run, ground distance, run, ground distance. You see? Mhm. So in our step two, we are going to be calculating for the rise. So this is the step two. This is our step two. Okay. So we said that our rise equals to what? Difference in elevation. Okay. And so that is our rise. And going to be what? Or we say our rise equals to changing and changing something in the final one of the initial one, right? So that is going to constitute us to get let me write it over here. And that is going to we say that our rise is the same as change in elevation. So it's change in elevation. Change in elevation. And so we can quickly proceed right away from here. So we can say that our rise is equal to, maybe it's a change of something, something minus something. Okay. So that is going to give us what 52. 52 minus 50, which is going to give us 2 meters. So you say that our rise is just 2 meters. Our rise is just 2 meters. Mhm. So now we can now calculate for the average period. Okay, now step three. Step three. Let's do name this step three. Good. So we can now calculate for our gradients.
All right. So since we are saying that the gradient is equal to rise over run, at the end of the day, we just have to substitute the vertical distance over the horizontal distance into it. Okay. But take note that it must always be expressed as a percentage. Okay, so always remember to multiply times 100. So that is times 100. So finally, we can calculate for our slope the fastest way. Okay. So the slope now will be equal to, let me say 2 over 24 times 100. So let's all count that together. 2 over 24, 2 over 24 times 100. We're going to get 8.83%. So therefore, the average gradient, therefore the average gradient or the average slope is equal to 8.83%. 8.83%. So let's proceed. Let's proceed to solve question 4. And question 4 talks about Chainage. Yes, question 4 talk about Chainage. Okay, let's see what the question entails. On a site, it says on an existing road, resurfacing is to be undertaken for 2,555 meters, beginning from station 4 kilometers, 355 meters. What is the station or Chainage at which the resurface road end? Okay, the question is the question that they're asking is that they want the answer in the form of a what? A Chainage, okay, or a station. Okay, so no matter what, at the end of the day, you have to still leave your answer in the form of a Chainage. This number you are seeing over, you can see 255. You can see 255 like this over here. Or if you have a number such as this, okay, always the first one is normally considered as kilometers, and then the rest can be taken as meters. Okay. Um, in saying that, an example, if you have something like zero, you have something like 0 plus what? 0, 0, sorry. See, this is the bigger one, this is the smaller one. See, this is the K, and then this becomes meters. See. So these are the two differences you should be able to know. Okay. Mm. And you should also know how to be able to write Chinese into meters and vice versa. Good. So the resurfacing length was 2,555 meters. Okay. Now that if starting from a station of 4 plus 355, which means let me say 4,000 meters, like 4,355 meters. Okay. From the datum point, yes, that is the meaning of the question. So we are being asked to find the ending station. So given in the first one, we have to calculate what the speed. Good. First of all, we have to convert the starting station. Okay. We can convert the starting station into meters. We have to convert the starting station into meters, and then at the end of the day, we can add it to the meters. Then later, we convert it back into what? Change. Okay, so let's quickly do that and see something. So this is a solution of that.
Good. So let's proceed. So first of all, we have to convert 4. The first one, we are going to convert this one, okay? Because at the end of the day, we are supposed to add. Or what we are going to do is that, first of all, starting point. Let's take the starting point at A. So we can say that A is equal to what? Starting point. Or let's say A is equal to what? 4 plus 3 plus 5. Okay, good. And also let's say B is equal to 2, 5, 5 meters. Okay. Now let's go and read the question again. An existing road resurfacing is to be undertaken for 2,555 meters. Beginning from this, what is the station at which the resurface will end? So you see, from the starting to the end, it means the question is just asking you to what? Add. You are supposed to add A and B. But if they are not collinear, if they are not in the same thing, you can't add them. Okay. So what we are supposed to do, you're supposed to add. So we are supposed to add, but look at what we are going to do. So we have to add them. A plus what? B is going to give us what we are looking for. So A plus B is equal to what? The end of station. So that idea, let's transfer that idea over here. If you want to try transfer that idea over here, you realize that the end of the station is going to be equal to the end of the station is going to be equal to what? Let's say it's still A plus B, okay? So let me do it this way, A plus B, okay? Um, so in my next step, I'm just going to use a tick. This is it. It's equal to now the A. This A over here can also be written as this. So you see, so this A is equal to what? 4, 3, 5, 5 meters. That is if you want to write it in meters. Okay. This guy is already in meters. But take note, as I told you already, that this is in what? km. And this in what? Meters. Okay, so let's proceed. So now that I'm done converting, these are the two people that I will use. Okay, then later I can bring it back. Where the question said that you want the answer in a form of a what? A Chainage. Okay. Better still, then we can choose to work in a Chainage form so that we will be on a more safer side. Okay, you can also choose to work that way. Okay, okay. So you can just be flexible. That is it. to make life much more easier for yourself. Anyone you wish. But just adopt this method. In our next example, we'll use the other ones. Okay, so this over here, let's go and add 4, 3, 5, 5. So we say that's what? 4, 3, 5, 5. Okay. Plus the B. 2. This one we forget to add 1, 5 to it. So let's quickly add it. You say it's 1, 5. Okay. So let me quickly put that down. And that is the same as 2. 5. So if you add this to, what are you going to get? When you add this to, that is 4, 3, 5, 5 plus 2, 5, 5, 5. We're going to get 6, 9, 1, 0. So that's going to give us 6, 9, 1, 0 meters. 6, 9, 1, 0 meters. Okay. But the question was asked. The question asked us to calculate our answer in the form of a Chainage. Okay. So this is the answer in meters. Okay. But Chainage is equal to what? But end Chainage. Look how I'm going to conclude the answer. So, but what? End Chainage. Okay. Exactly. But end Chainage is equal to 6 kilometers. As I always tell you, always bring the first one like this, then the rest can be history. Okay, so 6 kilometers plus 9, 1, 0 is, and you are done. And now with your solving, this is all you are supposed to provide. So let's proceed to solve question 5. Let's proceed to solve question 5. So question 5 says that the following figure, question 5 says that the following figure shows spot level on at 20-meter intervals over a site which is to be excavated to a site which is to be excavated to 47 meters to accommodate 2 tennis courts. Calculate the volume of material to be removed. Let's take it one last more time again. The figure shows spot levels at 20-meter intervals over a site which is to be excavated to 47 meters to accommodate 2 tennis courts. Calculate the volume of material to be removed. Calculate the volume of materials to be removed. Okay, let's see how we're going to go about this question. So first of all, we have to analyze the question. Okay, and part of analyzing the question is also part of being being able to resolve the question better. Let's take it one last more time again. A figure shows a spot level at 20-meter interval over a site which is to be excavated at 47 meters to accommodate 2 tennis courts. Calculate the volume material to be excavated. Okay. So you are being asked to calculate the volume of material to be excavated. Good. Good. Yeah, so in our solution, first of all, you realize that the distance between the grids are 20 meters. Okay, yeah, so if we have to calculate for the grid spacing and we have to multiply the 20 by 20. Okay, so first of all, our grid spacing is going to be equal to 20 times 20. Okay. So let's say 20 meter times 20 meters. We are going to get to 400 meters squared. And the excavation depth, site must be cut down to, let me say, 47 meters. Okay. So depth of excavation. So depth of excavation. The depth of excavation is equal to 47.00. Good. So from this idea, we can proceed. Okay. Mhm. And we want to use the average depth method. We want to use the average depth method. Yes. But we have to know that the volume is equal to the average depth times the area. Yes, volume is equal to average depth in the area. Okay. Mhm. So you're going to be doing a table right away. You're going to be doing a table right away. Yes. So this is the table I say we are going to be using. This is the table I say we are going to be using. Exactly. As you can see, this is the grid point, and then this is the depth of path. Mm. Also, for the formula we're going to use to calculate for the depth, our depth of cut is going to be equal to the existing level, or the grid minus the formation level, which is 47.00 meters. Take note, I said that we're going to be using the average depth method. Okay. So that is it. And our depth of cut, it's just the formula I'm going to put over here, and then life becomes much more easier. So depth of cut, with the depth of cut, depth of cut, you see, is equal to the level, existing level, existing level minus the formation level. Existing level minus formation level. Existing level minus formation level. Exactly. So that is what we have over there. Yeah, let me quickly align it boldly very well. Okay. So you can begin now. Mhm. So if you come over here, you see the grade. This first one is what? 46.1. This is 47.1. So you're going to be picking it in that order. You're going to be picking it row by row, row by row. You see, and the distance between them is what? This distance from here to here is 20. From here to here is 20. So that is why we are multiplying the 20, okay, times 20, okay, to get the area. That is 400 meters squared. You see the 400 meters squared we calculated for we had over here. That is how come we got it. Exactly. Mhm. So let's also come and calculate for the other one we have been asked to calculate for the volume to be hot. Exactly. So we say we're using the average depth. So we want to list all this one. 46.1. We're going to list it all like that. Okay. So you see me listing it all over here like this now. So I want to even shift this line inward a bit. Okay. Yes. So let me even shift this one inward. So that is it. Let's quickly write the numbers together. And the first one was 46.1. So this is 46.1, 46.1, 47.4, 48.4, 48.4. Now you're coming to what? 47.2. As you can see over here. 46.1, 47.4, 48.4. This is the mobile on the first row. You see. After 48.4, what do you have? You have 47.2. So that is it over there. 47.2. You see, we entered first for 1, 2, 3, 4. So I can't take the next for 47.8, 50.1. It's continuous like that. So this is 47.8, 50.2. Also, it's actually 50.1 and also 47.7. So 50.1, 47.7, 46.1, 49.5, and we have 50.1. Then we also have 47.3 and also 44.8. Okay. Yeah, so that is it. That is it. So we have to just come and fill in the other column. The formula is already at the top. Okay. So you're just going to pick the existing level minus the formation level, and then life become much more easy. So that is an example of what I'm going to be doing over here for you to see. Mm. So uh, this becomes this is going to become 46. Yeah, 46. So it is going to be 46. What is 6.1? Okay. Mhm. Minus 47.0. You see, the answer you get, you write it over there. I only do for a few, and then the rest I'll just write it because of the time. This is 47.4, right? Minus 47.0. That is what is happening in there. Also, this side is going to be 48. 0.4 minus 47.0. This is 47.2 minus 47. Point zero. So it continues like that to the end. Okay. So the answers are the main most important. So this one, if you do the subtraction, you are going to get what? Negative 0.9. This one, if you subtract, you're going to get 0.4. And this one, so you're going to get 1.4. Yes. This is going to give you 0.2. You're going to get 0.8. After that, I'm going to get 3.1 over here. 3.1. It's the same, you'll be subtracting the 47.0, and this is where the 47.0 came from all your grade points. You're subtracting it from all these grade points. See, so it's not anything foreign, there's nothing new, but still the same thing we have been playing with. All right. All right. And this is also going to give us 0.7. This is going to give us a negative answer. We say we don't like negative answers, so we're going to ignore it. We'll see that soon. So that this one gives us 2.5. This one gave us 3.1. And also this will give us minus 2.2. Yes. So this is how our table is going to look like. Okay. You can see how the finished solving of the table looks like. So as I was saying, the negative ones, we will not consider them. Okay, like these two people over here. The ones that we had the negative answers, this guy and also this guy, we will not consider them in our calculation. Okay, but the rest we will consider them. Okay. So now we are going to calculate for the average depth of cut. Okay. So we're going to add all and then we divide by what? We're going to add all and then we divide by the number of cuts. We divide by the number of cuts. So that is what we're going to do. That is what we're going to do right now. How many negatives did we have? You see, this one was also part. Okay, that can tell the whole process. So our number now has reduced to 9 instead of 12. Okay. So finally, we say we are now coming to calculate for the average depth of cut. Okay, so now this is our average depth of cut. This is the average depth of cut. Average depth of cut. Now, so we are just going to add all our parameters and then we divide by the number of items, okay, or the number of points. So That is going to give us something like this. So our average depth, okay, or the mean, can now to be said to be equal to what? The sum of the relation all over the number of occurrences. This one, which I believe we all know, so I'll just trade it. I'll just solve it straightforward, and then we're all good to be. So this is it. So this is it. So first of all, the first one we had was 0.4. You see, because the 0.9, so we are going to start from this. So that becomes, I can change a different color pen to enhance the process. So that becomes 0.4. 0.4, okay, plus 1.4, okay, plus 0.2 plus 0.8 plus 0.1, 0.1 plus 0.7 plus 2.5 exactly plus 3.1 plus let's say 0.3. We say we are not considering the ones with the negative number. So let's quickly add all together. Let's add a numerator. That is 0.4 plus the 1.44. Let me reclaim this one and write it all so that it doesn't confuse us. So 0.4 plus 1.4 plus 0.2 plus 0.8 plus 3.1 plus 0.7 plus 2.5 plus 3.1 plus 0.3. We're going to be getting 12.5. Okay, so I can repeat the equation again. And that is going to give me something like 12.5. 12.5. So we see that our final, or no, let's say our mean, okay, our average, okay, our average depth, our average depth. So let's say our average depth. So therefore, we can say that our average depth, our average depth, our average depth can now be said to be equal to the answer we had. This is 12.5. 12.5 exactly. So you see, it's just a matter of punching it into the calculator. The rest is no longer. The rest becomes mathematics. So 12.5 divided by 9, we're going to get 1.388888. So we can just run it to 2 decimal places. So this is the answer we are getting. That is 1.3 meters. We can choose to maintain just two decimal places for the purpose of our work. So take note that the grade is 3 rows. Okay, and then the columns are 4. So you're going to multiply 3 times the 4, giving us 12 squares. This is it. Look at the grades. This is row 1. So let me name it. Let me use a different color thing. So this is row 1. This is row 2. This is row 3. See, this is column 1. This is column 2. This is column 3. This is column 4. So at the end of the day, there are 12 squares. There are 12 squares. At the end of the day, there are 12 squares. So at the end of the day, each square too is, let's say, 400 meters squared. There's 400 meters squared as we calculated over here. Exactly. So what we're going to do is that you have to also know that the total area is going to be the 12 times the what? 400. Let's quickly do that now. Let's quickly do that to get a total area. Now we know the area of a single, the 400 we had over here is just the area of a 400 meters squared. It's just the area of a single one. So the area of one, so what about the 12 squares? So you see, let's solve that beneath. So we say we're looking for total area of site. In this case, now we want to calculate for the total area of the site. Let's put it over here. Total area of site. The total area of site. Total area of the site. So total area of the site. So the total area is just as I told you, it's going to be what? 3 rows times 4 columns. Okay. Is equal to 12 squares. Um, so, but each square is equal to what? 400 meters squared. From whatever I told you initially. See, but each square is equal to 400 meters. But each square is equal to 400 meters squared. So the total area is going to be 12 times 400 meters squared. You see, so that is what you're going to get. So the total area. So finally, we can say that our total area. So we can say that the total area. So the total area is equal to 12 times 400. And we're going to get 4,800. Four thousand eight hundred meter squared. Okay. Our final step. Now we're now coming to calculate for the what? Excavation volume. So the volume of excavation is just what? The average depth times what? Area. Average depth times in the area. When we calculated for the average depth, so what did we get? We had 1 point. This is the answer we had, right? This is the answer we had for the average depth. So you see that this is of some few stages here. So let's proceed to use our final formula to solve the final. Let's wrap up. So the excavation volume. So the volume of excavation finally. Let's put it over here. So this is the volume of excavation. Volume of excavation. So the volume of excavation, that is what they want to do finally, and then see how best we can wrap up. So the volume of our excavation, one, is equal to average depth times area. So in this case, our volume is equal to average depth times area. Average depth. Average depth times the area. Average depth times the area. Okay. So finally, we can just do the substitution and then we are good to go. So finally, we can say that our volume is equal to, and the calculation of the average depth. So remember, we had 1.3889. So that is 1.3889 times the whole total area. It's not just any area, but it is total area. Let me write it well. That is the total area. Total area. So the total area was 4,800. 4,800. So this is it, 4,800. Yep. So finally, therefore, let's see that our volume is equal to, let's all quickly point this together. Let's all quickly point this together. And that is 1.3889 times 4,800. So I'm getting 666. Okay, so let's all write that down. And I'm getting this value 666.6 70. Yes. Meter cube. Okay. So that is the volume I'm getting. Okay. And so the volume of material to be removed is approximately this. Okay, the volume of material to be removed is approximately this. 6,666, 6,666.76, 72 meter cube. Okay, yes, so that is it. That is it. Let's look at something over here. But the question says we should calculate the volume of material to be removed. So that is the volume of excavation. Volume of excavation or material to be removed. So don't get confused. Better still, I can write it in that way so that you don't get confused. So this is it. Please, in a very big place, don't forget to throw $1 on my name if you find this video very helpful and very, 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 very good. Yes. Okay. This is the volume of material to be removed. Okay, it's the same as the volume of excavation. It's the same as the volume of excavation. So that is the volume of material, volume of material removed. Volume of material removed. What is it? Volume of material removed. So we just have to just wrap up and see if we can solve the other ones. Then life can become much more easier. What other question do we have? Yes, yes. This question says that to sketch a simple circular curve and label the part. As you can see, this are the various parts of a circular curves. Take clear look at them and you should be able to draw it. You know, you should be able to draw the simple circular curve and label the parts. You also be able to know what vertical curves are. Okay. You're able to know what vertical curves are. You should be able to mention the types of vertical curves. All of those are reading savvy. That is why I didn't want to bother to talk much about them. This is also an example of a simple circular curve over here, a simple diagram. So just practice it. And I believe that life is going to become much more easier. This question is saying that we should the following, express the following percentages, or we should express the following percentage rate as fraction. We have to express the following as fractions. How do we go about it? We're supposed to express the following as fractions. So it's just similar as what we have been doing earlier. You see, whatever we did in the past is the opposite of what we are doing over here. Express the following percentage grade as a fraction. Express the following percentage grade as a fraction. It's just as simple as that. This is almost in its fraction state already. So 25% is the same as 25 over 100. And it works that way. It works that way. So you say that it's not anything too difficult. We're going to work it out now and then life is going to be easier. So this is my solution. Yeah, so let's take I. Let's take I, and I is what? 25%. Okay. This 25% is the same as what? So this is the same as, let's say, 25 over 100. 25 over 100, which is the same as 25 will go into 7 once and go here. How many times? 4 times. is the same as 1 over 4. Okay, so you see what we are having over here, and that is the end of it. Let's take the other one. So this is I. Let's put the last one over here, I. So our next question is 1.66667%. And that is simply equivalent to 1.666 over 100. 1.6667 over 100. At the end of the day, we are going to be getting something different. Okay. And in this case, a different thing altogether. So this is going, because the more this is coming, the more zeros you're going to be adding. So normally the decimal point is supposed to be. So how many zeros? How many movements must we move? Okay, so this is going to be 1, 2, 3, 4. So we just have to add one. Let's do the movement once more time again and have a look at something. Maybe I overwrote something. So this is how it is working. Okay, so this is it. Okay, so this one, first one is going to move this one 1, 2, 3. Okay, so that's going to add 3 zeros to this. So we are going to get what? 1, 6, 6, 7, all over 1, 6, 6, 7, all over what? All over 100,000. 1, 2, 3. You see, to simplify this, we can choose to simplify this in a more simpler thing. Okay. And in doing so, we realize that we can write it in the standard form. Okay, or we can write it in a simplified form. Okay, and that is expressed as this. Yes, so we can choose to write this in standard form to simplify the solution too. Okay, so just as I was saying. So you have a look at something. So this can also be written as what? Let's say 1.6. Okay, 67 times 10 times 10 exponent 3 all over what? 1 times 10 exponent what? Let me say 5. You know that from indices, this is equal to 1.667. Okay, now times 10 exponent what? 3. Okay, but this is going to become an inverse, so it's now going to be 10 exponent negative what? 5. Okay. If you continue to simplify this, we are going to be left with this. If you multiply this, we're going to be left with, because in indices, if the bases are the same, you have to add the exponent. So this alone will give you what? 10 exponents, negative 2. So you're going to be left with 1.667 times 10 exponents what? Negative 2. Which finally is going to lead you you get something like this. I told you the other day, if you have something like this, it can also be written as this. To be on a more, this over here means two zeros came before even the numbers that come. Okay. So this is the same as 0 point what? 0, 0.016667. Okay. 0.01667 is the same as 1 over 60. Okay. It's the same as 1 over 60. It's the same as 1 over 60. Approximately. Okay, so let's let's proceed. Let's proceed to solve the last one, which is I. So this is I, I. And then our question says we should convert 60, let's say 6.535%. So 6.535%. So this is 6.535%. So this over here, we can say that hot 6.535 percent is the same as 6.535. So all over hot 100. Without beating about the bush, we can make it more simpler this time. Okay. So this 100 can keep shifting this zero. So it's go like this. 1, 2. So it's going to be, we're going to be left with 0.0 6 0.065335. Okay. All right. So as simple as that. As simple as that. But we are not being asked to express our answer in a form of, let me say, decimal. We are supposed to express our answer in a form of a fraction. Okay. So take note that this over here, let's say 0.06535 can also be written as what? Can also be written as, let's say, 6.535. 6.535 times 10 exponent -2. You see, times 10 exponent -2. And this over here is the same as what? 6.535. times what? 1 over 10 is 1 over 10 exponent 2. Okay. I could have solved it straightforward. Okay. I just want to play around the mathematics so that you see how the science is working around it. Okay. So that if you ever find yourself in a stage, it is flexible. Okay, it is very, very flexible. You can play with it all around like that. But just make sure you are doing the right thing. Okay. So at the end of the day, this over here is going to still give you what? 6 point what? 535 all over what? 10 exponent 2. Okay. Put this will give you what? Let's say 6. This over here will give you what? 6 point 535 all over 100. You see what is happening over here? Exactly. Let's come and conclude our final answer from whatever experience I gave you initially. So from whatever we learned initially, we can now finally say that what if we move these zeros to the other side, 1, 2, 3. Okay, we're going to add 3 more zeros to the denominator. So let's quickly add it 3 more zeros. So that is going to become 100,000. 1, 2, 3. So that is going to be 6, 5, 3, 5. Because initially it was like that before. Anytime you see that's what should come in your mind. Okay. So this is what you're going to get. And uh this over here, let's quickly punch 65 35 all over 100,000 in our calculator and see what you get. Okay. In a simplified form, it can also be written as 1 3 0 7 over 20,000. So you can conclude your answer in this simple way. You can use a simpler approach, okay? For teaching purposes, I just have to be dynamic so that each and everyone gets equal share of their knowledge. Yeah, so last but not the least question is a contours question. Yes, let's quickly look at them and then we'll see how best we can wrap up for the class. Um, So our question is saying that what is the distance between 2 points A and B? This time they're asking about the distance between 2 points. The distance between 2 points A and B. If Chainage A is 6 plus 045 and B is 8 plus 110. Okay, so this time since they are all in Chainage and they want the answer in the form of a distance, it means that even after calculation, we have to convert it into distance, you see. So this is our solution. So this is our solution. So our solution is as simple as that. So let's say we have to subtract A from B. Okay, so our solution is what? It's as simple as that. B minus what? Anytime we hear distance, it's different. So you should know that you're always going to subtract final velocity minus initial velocity. Okay. But we have to do the convention. You see. So I say that but but we are seeing B is equal to, and H is also equal to this. Okay, so but B is equal to, let's say, 8 plus 117, which is the same as what? 8,110 meters. Okay, this Chainage is also equal to what? 6 plus 0.45. 6 plus 0.45. So this in the form of meter is going to be 6,045 meters. Okay. So finally we can subtract. Finally we can subtract to get our answer. So if you see me putting asterisk over here, it's just a key point. Please don't forget to subscribe to the channel. Don't forget to like the videos. Don't forget to comment so that motivation can be improved to enhance the process. Thank you very much. So finally, what are we going to do? Finally, what are we going to do? We just have to subtract, okay? So we say that 8, 1, 1, 0 meters minus what? 6, 0, 4, 5 meters. And finally, we are going to get our answer. Okay, so finally, that's the distance. So you see, 8,110 minus 6,045. We're going to get 2, 0. We're going to get 2,065. 2,065 meters. And that is going to be the hot answer because the question is what is the distance? The question was looking for distance, and distance is measured in meters. You see, if it was a Chinese, you have to leave your answer in the form of a Chinese. Okay, I told you that Chineses are written in this form, something like 0 plus what? Even if you see something like this, a Chinese, so don't get confused. So that is it. So the question was, what is the distance between 2 points? Okay. 2 points A and B. If A is equal to that, then so we have to subtract to get the answer. Okay, let's also look at the other question. Let's also look at the last question for the day, and then we wrap up. So this question is saying that a point B is a point B. A point B is 1,550 meters ahead of another point. Ahead is a punchline. You see, it's a keyword. So ahead of another point, A, whose station or Chainage is 0 plus 625. What is the station? What is the station of point B? What is the station of point B? You see, so the station of point B is mean that we should add because ahead, the word ahead should draw your attention to something. Okay, so we are supposed to add. So in our solution, because the question wants the answer in the form of a Chinese, we have to provide an answer in the form of a Chinese. Okay, that is good. We can either even start by converting everything to Chinese so that our working can be beautiful and more easier. So let's quickly do that together. Or we can also choose to work the vice versa, the other way around, the other way around. Yes. So this is our solution. This is our solution. This is our solution. Yes. And in this case, the rule we have adopted, we are going to add, that is A plus B. Okay, but they must all be in the same form. Okay. So because of that, what are we going to do? Let's list them out. If this is the A, and then this is the B, what do we realize? Let's write the A down. The A's challenge is, let's say, 0 plus 625. So this one is in the form of a challenge already. But the B was given in meters. That is 1,550 meters. Okay. So we have to convert the B into a Chainage. Okay. And that is going to give us something like this. So you see 1 plus 5, 5, so finally we are good to go. So the addition of A plus B is going to be of this thing. So we are going to do this one. So now we can add. We can now add A plus what? B. Mhm. So that is going to be, let's say, the A is 0 plus 6, 2, 5. See? And then the B was 1 plus 5, 5, 0. So let's quickly work together. Let's quickly work together. So this is the A, and this becomes our B. No. So let's all quickly point this together. Let's all quickly point this together. So this itself is going to give us how much? If you add this is going to give you 5. This is going to give us 7. This 5 plus 5 is 10, plus 1 is going to give you 11. So you see, bring one, but we have to bring our plus. Then we carry the rest. See, add 1 to this. So at the end of the year becomes what? 1. It's no more 0. And so 0 plus 1 now becomes 1. And then here becomes what? 1 plus 1, 2. I believe the calculation is clear for you. So therefore, we can say that the station of Chainage is that. So let me conclude. For the question say, what is the station of point B? Okay. What is the station of point B? Station and Chainage are the same thing. So therefore, the station of point B is, so let me put it over here. Yes. So the station of point B is 2 plus 175. So that is it. That is it. Okay. So the station of point B is 275. 275. So that is it. That is it. The station of Chainage, or it's believing with Chainage. to the station or chainage of point B. The station or chainage of point B is 2 plus 175. Okay. Yes. So at this point, my name still remains Megabyte the physicist, and then I'll urge each and every one of us to try and then watch the lecture videos. Okay. If you have any question, try and ask me. Okay, so that I assist you out. Okay. Uh, Try and ask more questions to aid your understanding. Also solve more of past questions. Okay, solve more past questions, and that will help you far better. Okay. This is only to serve as a guide. Okay. And as to what to help you to be able to understand whatever you will not be able to understand when you were in the course of the semester. Thank you very much to all who also supported to make this very effective. I really appreciate you all. On this note, my name still remains Megabyte, the physicist. I appreciate you all. May God richly bless you all for your time. Thank you. Bye bye.